Hey guys, welcome back to the QSC YouTube channel. Today we'll be solving the Term 3 Week 4 Chemistry quiz. Which of the following are not properties of noble gases? Okay, so noble gases are, for example, helium and argon, Ag. Okay, no, it's not Ag, man. Helium and neon, for example, are noble gases. They are in group 18 or like in Roman numerals group 8. Their melting and boiling points increase down the group. So as they go down the group, boiling point and melting point increase. Group. Okay. Noble gases are also unreactive, so which is why they exist in the monoatomic state. Unreactive is basically the same name as it's the same thing as inert. Okay. So they are no so their melting points and boiling points increase down the group, it doesn't decrease, and they are not highly reactive. We chose the wrong answers because they're asking here which of the following are not properties of noble gases. Number 2. Which of the following symbols refers to heat content of a substance? This is, to be honest, memorization. It's just the letter H. Whenever you see heat content or anything related to heat, it's always H. Except if it's specific heat, which we'll take later. So there's no need to know about it now. Number 3. Which of the following are examples of endothermic processes? Endothermic processes are reactions that need energy. So let me solid, liquid, gas. So melting an ice cube. So here. So when we're making it from solid to liquid or liquid to gas, it's endo. But the other way around, it's all exo. And from liquid to solid, it's exo. Okay. Heating carbon with water vapor to form hydrogen gas. So this is something to memorize as well. Okay. Cooling water vapor is basically going from gas to liquid, and it's exo. Reacting NaOH with HCl is a neutralization It's a neutralization reaction where acids react with bases, and that's exothermic. Number 4. Which of the following atoms is an unreactive monoatomic gas that has an atomic number Z equal to 2? Z is, as we said, the atomic number equal to 2. In the periodic table, it will be hydrogen with an atomic number of 1. Then on group 8, it will be, group 18 with helium with atomic number of 2. Number 5. Which of the following describes the chemical properties of an element? Okay, so this is an element X, Z, A. A is the amount of protons, neutrons, or nucleons, while Z is protons. Each element has a different amount of protons, which is why, the amount of protons decides the chemical properties of an element, which is the atomic number. Number 6. Which of the following statements is true about an electron in an isolated atom? Okay, so let me draw the model for an isolated atom. So this is the nucleus, protons and neutrons inside, and then on the outside there'll be electrons all around here. So these are all electrons, the ones on the outside, and they move randomly around the nucleus. They're not inside, they're around the nucleus. Number 7. Which of the following statements are true about ion formation? Okay, look. So let's say we have the nucleus here with the electron, like, how can I say this? The electron orbits. Okay, so now let's say we have electrons here. Okay, now to create a positive ion, right, we need to remove this electron. So by removing it, we need energy, which is why energy is absorbed when a positive ion is formed. And it's the opposite for a negative ion. So energy is absorbed when a positive ion is formed, and it is released when a negative ion is formed. Number 8. Which of the following are common characteristics of nuclei of the same element? Okay. Nuclei of the same element have the same nuclear charge, and the same number of protons. They don't have the same, not all of them have the same number of neutrons, because some of them are isotopes of each other. Nucleons is protons and neutrons, which is wrong. And same number of electrons is wrong because it's not in the nucleus. Question 9. Choose the correct answer to complete the sentence. The change in the heat content. Okay, so as we said before, heat content is represented with H. And change in anything, even in physics or math, change is represented with delta or triangle, which is why delta H is the answer. Number 10. Choose the diagram below shows a representation of a set of atoms and ions. Okay, so look, let's define atoms and ions. Atoms are basically neutral. So atoms are neutral. So atoms means the same amount, protons are the same amount as electrons, right? Okay, protons then electrons, they're equal, which is why A, B and E, I hope it's clear to you guys that like the amount of protons is equal to the amount of neutrons. Okay, an ion is basically when, look, a positively charged ion is when protons, which I'll represent as P, are greater than electrons, and negative ions are when the number of electrons is greater than the number of protons. So a positive ion like C has 1 proton but 0 electrons. A negative ion, which is D, has 2 electrons and 1 proton. Number 11. The numbers of protons in an atom is represented by its atomic number. Locate the diagram that represents an atom with atomic number 2. Okay, look. So atomic number, as we said here, let me show a demonstration. So here the Z is the atomic number or number of protons, and A, or up will be the amount of nucleons. Nucleons are protons and neutrons added together. So an atom with atomic number 2 will have will have two protons. This has one proton, this one has one proton, this has two protons, this has one proton, and this has one proton. So it's this one. Number 12. The mass number of an element indicates the number of protons and neutrons. Okay, I already explained this in the question before. So look, let me draw this. X1, 2. Okay, now we need to find the amount of neutrons to find out like how many like neutrons do we need. Neutrons, okay, is this like the mass number minus the atomic number. So we have one neutron and one proton. Okay, let's find the atom with one proton and one neutron. This has two protons and one neutron. This has two neutrons and one proton. This has one proton, one neutron. This has one proton and no neutrons. So it's this one. Okay. Now we move on to question 13. A chlorine atom has 7 valence electrons as shown below in the diagram. Let's go one by one. So let's start with chlorine. So Cl. Chlorine has 7 valence electrons because as you can see it's in group 7. 1, 2, 3, 4, 5, 6, 7. And this is another chlorine. 1, 2, 3, 4, 5, 6, 7. Okay, so look, each chlorine needs one electron, so two chlorine atoms will share one pair of electrons. One pair of electrons is 2 electrons, so they will share one pair of electrons. So now it will have, now this one will have 1, 2, 3, 4, 8. 1, 2, 3, 4, 5, 6, 7, and 8. And then the other one, the one with X, has 1, 2, 3, 4, 5, 6, 7, 8 electrons as well. This is a single covalent bond. Okay, now they want with oxygen. Oxygen, 1, 2, 3, 4, 5, 6. Then let's draw another oxygen. 1, 2, 3, 4, 5, 6. Now oxygen is in group 16, meaning that each oxygen needs 2 electrons. So this oxygen will share with the other, and then this will be shared with the other one. This will make each oxygen have 8 valence electrons, which is noble gas configuration. This is known as a double covalent bond, which means it shares 2 pairs of electrons. Okay, now nitrogen. This, okay, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Now nitrogen is in group 15, meaning that it needs 3 electrons that each nitrogen needs 3 electrons to get noble gas configuration. So this will share with this will share with this, and then same over here. This will allow each nitrogen to achieve noble gas configuration by sharing 3 pairs of electrons, which is called a triple covalent bond. Number 14. Given the following elements and their group numbers in the periodic table. Okay, now let's define each type of bond. Ionic is a basically metal plus a non-metal. For example, NaCl, which is table salt. So NaCl, for example. Meanwhile, on the other hand, covalent is two non-metals. Two or more non-metals. Okay, now from group 1 to 13, that is metals, and then from group 13 to 18, not 13, sorry, 14 to 18, that's non-metals. Okay, so let's start with KCl. K is in group 1, which is a metal, and then Cl is a non-metal because it's in group 17, so it's ionic. Nitrogen trichloride. Nitrogen is in group 15, which is a non-metal, and chlorine is in group 17, which makes it a non-metal as well, which is why the bond is covalent. Nitrogen, okay, this is nitrogen gas. So as we can see here, nitrogen is a non-metal because it's in group 15. So yeah, so that means two non-metals are bonding together. Number 15. Isotopes are defined as atoms of the same element that have the same atomic number but different mass number. So let's say we have hydrogen 1, 2, then hydrogen 1, 1. These are the same element but just different different mass number. As we can see here, they have the same mass number but different atomic number. Oh my god, I keep mixing this up, sorry. They have different mass numbers but same atomic number. Okay, so let me remind you guys with the model of an atom. X, Z, A. Z is the amount of protons, A is the amount of nucleons. So when Z is equal to 1, that means there is only one proton. So let's count. 1 proton, 2 protons. We don't care about neutrons. As long as there's one proton, it's the answer. One proton and the other we don't care. $60. Okay. Fill in the table to determine the number of subatomic particles in given ions. Okay, so Cl minus 1735. Okay, so first the amount of protons is gonna be the number at the bottom, which is 17. The neutrons is gonna be the mass number minus the atomic number, which is 18. And now to find the electrons, look, if let's say here -2. Okay, that means there will be 2 plus the amount of protons, or 2 plus z. So in this case it's -1. So 17 plus 1 to find the electrons is equal to 18. Okay, so let's do aluminum. So Al 3 plus 13 27. As I said, the number of protons is at the bottom. The number of neutrons is the amount of is the mass number minus the atomic number, which is 14, and then the electrons. So let's say it's 2 plus, we do the atomic number -2. So we switch the sign basically each time. So now we do 13 minus 3 to find the electrons. We get 10. So we have 10 electrons. Okay, sodium 2311. 1123. We have an A plus. We have 11 protons, and we do 23 minus 11 to get the neutrons, and to get the electrons, since here it's plus, we do 11 minus 1 is equal to 10 for the electrons. Okay, S2 minus 16 and 32. There will be 16 protons because the Z is 16. There will be 16 neutrons because if we do 32 minus 16 to get the neutrons, we get 16. And then to get the electrons, here since it's 2 minus, we do the Z, which is 16, plus 2, which is 18. Okay. (17). An atom is represented by the atomic symbol Az. Choose the correct answer to complete the following. The letter A, which is at the top in this case, is the mass number. The letter Z in the symbol is the atomic number, which is the number of protons. Okay. Consider the atomic symbol of bromine. 35, 80. Okay, so we have 35 protons because the Z is 35. Since here they said it's a bromine atom, so the number of protons will be the same as the number of electrons. Okay, and for the number of neutrons, as we said before, we do 80 minus 35 to get 45. Okay. 18. Calculate the heat change when 3.2 grams of methane is burned in excess oxygen. Okay, so first of all, let's try to find the number of moles of methane. So we do 3.2 over 12 plus 4 times 1, because there is 4 hydrogens, which will be equal to 0.2. Okay, so let's compare the equations and make a ratio. So here there is 1 mole, which will give negative 819. So 1, 2, negative 819. So 0.2 to x. We cross multiply and we get that x is equal to negative 164 kilojoules. Number 19. A halogen X2 reacts with an atom A by sharing a pair electron to produce a compound AX. This is a compound which you have to memorize, which is something I did as well too. Like each time I saw this question, I'll just put HF. Yeah, so that's it. Number 20. The electrical conductivity of metals is caused by the presence of loose electrons in the crystal lattice. Okay. Number 21. Alkali metals are soft and malleable. Okay. Alkali metals form +1 ions. This is because alkali metals, which I'll call Am, are in group 1, which is why they form +1 ions. Alkali metals are good conductors of heat and electricity. This is obvious because they're metals which are also good conductors of heat and electricity. NaCl is a very stable ionic crystal because it is built up of charged particles that have a noble gas configuration. Okay, so the NaCl crystal lattice is basically a cube. I'm not that good at drawing it. Just gonna. So here is 1 Na, then Cl, and then you keep going, like 6 Cl's for every Na, and then for every Cl there will be 6 Nas. So it's a very large crystal with a very complex shape. They are formed up of charged particles because Na is an ion or a metal, and then Cl is a non-metal, and it's charged since we use Na plus and Cl minus. And they are trying to get noble gas configuration, so the compound is stable. Like every single element when it reacts, like most elements when they react, they are trying to achieve noble gas configuration, which is oh my god, I hate stuttering. Anyways, it is when the compound is very stable and has a full set of valence electrons. Sodium will lose 1 electron because it's in group 1 and it's a non-metal. It's a metal. Chlorine will gain 1 electron because it's a non-metal and it's in group 17. Number 23. Neon, argon, krypton, xenon, and radon are noble gases. They are very stable, as we said in the first few questions, and under certain conditions they form extremely reactive compounds. Number 24. Drag and drop the correct boiling point. Okay, so noble gases, which I'll represent as NB, down the group increase in boiling point and melting point. Boiling point, melting point. Okay, unlike alkali metals, which will be shown in a future question, I don't think it's in this quiz though, down the group there will be a decrease in boiling point and melting point, only for alkali metals. Okay, so as we can see here, as we go down the group, we know this by the atomic number, we just keep increasing the boiling point. Same happens with the melting point. Number 25. The elements inserted between columns 2 and 13 in the periodic table form colored compounds, and more than one charged ion are called transition metals. Okay, so let me do the periodic table. For example, Okay, so here alkali metals, they form plus one, and over here alkaline earth metals, which we didn't take yet, just alkaline earth metals. Then from here, which is group 3 to 13, we have transition metals, and then here we have halogens, and then on the last group we have noble gas. So as they said here, from columns 2 to 13, they're called transition metals. Number 26. Atoms have a positively charged nucleus around which negatively charged particles called electrons move. Okay, so let me draw another like demonstration of a nucleus. Here are protons and neutrons. Look, a nucleus is positively charged because there are no electrons like inside the nucleus to make it negative charged or neutral. So, and then there will always be electrons moving. Atoms have diameters in the order of 10 to the negative 10. Number 27. Complete the following table. Okay, so here they said aluminum has an atomic number of 13, which means it will have 13 protons and 13 electrons, because they didn't mention if it's positively or negatively charged, so it's neutral, meaning that the protons and electrons are the same. And then to find the neutrons, we do the atomic number minus the mass number minus the atomic number. Beryllium. Okay, here they said protons of beryllium are 4, which means the atomic number is gonna be 4 as well. Since again, just like aluminum, they said that it's neutral, so the protons and electrons are gonna be the same. And then again, to find the neutrons, we do the mass number minus the atomic number, so we get neutrons as 5. Bismuth. They give us the atomic number, which is the protons. Since again, they didn't mention the charge of bismuth, so it's also gonna be neutral, meaning the protons are equal to electrons. And then again, to find the amount of neutrons, we do 209 minus 83 to get 126. Barium ion 2 plus. Okay, look. So here they said protons are 56, which means the atomic number is 56. Since here, as we said before, since let's say it's 2 plus, we do the protons minus 2. So 56 minus 2 is 54. And then we have the neutrons, so we just add the protons and the neutrons to get the mass number. Chloride ion. Okay, so they gave us the atomic number, which means protons is the same as the atomic number. Here, let's say it's negative or 1 minus 1, same thing. So we do 17 plus 1, which will give us 18. And since here they gave us the mass number, we can do mass number minus atomic number to get the neutrons, which is 19. 28. Lithium chloride, sodium chloride, and potassium chloride have the same chemical properties in order to distinguish. Okay, so look, let me make a table. Lithium, sodium, potassium. We have red, orange, yellow, and lilac or violet. Same thing. So lithium is red, sodium is orange yellow, and potassium is purplish or lilac. Number 29. drag and drop the correct boiling point of each species. Okay, so as I said before, alkali metals down the group, boiling point and melting point decrease, which is why we can see here it just decreases each time. $30. Write the equation for the reaction of potassium with chlorine. Okay, look, potassium is always solid, so potassium plus chlorine, which is diatomic, Cl2, to give KCl. Okay, now we're gonna have to balance the equation. So here it's chlorine is 2, so that means we're gonna have to multiply this by 2. And now if we multiply KCl by 2, that means we have 2 potassium, which is why we're gonna have to multiply potassium by 2 here as well. Okay, write the equation of the reaction of potassium with oxygen. So K plus O2 will give K2O. So okay, so here in this case, since we have 2 oxygens here and 1 oxygen here, testing. Okay, so we're gonna have to multiply the K2O by 2, and which will make the potassium 4, so we're gonna have to multiply it by 4 as well. Okay, the last reaction is a special reaction with potassium and water, so K plus H2O will give KOH and H2. KOH plus H2. Okay, so now we have 3 hydrogens on this side. So to balance it out, we're gonna have to multiply this by 3. Or wait, sorry. We're gonna have to multiply this by 2, so this will have 4, and then if we multiply this by 2, there will be in total 4 hydrogens. Okay, which will also balance out the oxygens. So the only thing that's left is that there is 2 potassiums, so we just multiply potassium by 2. Okay, thank you guys so much for watching this video. We wish you guys the best of luck in all of your exams, and goodbye.